Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 20. The question says, an infinitely large layer of charge of uniform thickness T is placed normal to an existing uniform electric field. Presence of this charge layer so alters the electric field that it remains uniform on both the sides and assumes value E1 and E2 as shown in the figure. Charge distribution in the layer is not uniform and depends only on distance from its faces. Find expression for the force per unit area experienced by the charge layer. So as per question, what was there? There was uniform electric field E shown as a red color in this diagram. This charge layer was not present initially. And this charge layer is infinitely large. When this charge layer is introduced in E field, E uniform field, the change happens. And what is that change? On the left side of this layer, the electric field becomes E1 as shown in here, and on the right side it becomes E2 as shown here. So let us say because of this charge layer, the E field outside this charge layer is E subscript Cl. Cl is for charge layer. We have assumed the positive charge layer. So ECl on the right side will be in this direction, and ECl on the left side will be in this direction. Since it is an infinitely large layer of charge, so this will be uniform outside and perpendicular to it. If we calculate for the left side, we can get that ECl was on this direction and E was in this direction. So E1 will be your E minus ECl. On the right side, ECl was in the same direction as it was E2. So E2 will become E plus ECl. So if we add these two equations, ECl will cancel out and E will be coming as E1 plus E2 by 2. What is being asked in question? To find out the force per unit area on this charge layer due to the E field initial. When this charge layer was not there, E uniform field was present. So that force will be, if the total charge on this charge layer was Q, then Q into E will be the force. So if E we already got in terms of E1 and E2, which which is known quantity. So if we calculate for Q and we'll find out Q, we will be able to get the force on the charge layer due to the E field. Now in the question it is given the charge layer, this is infinitely large charge layer and the entire thickness was T. So layer was like this. Few layers I have shown by red linings for understanding. And in the question also it is given from the left, means the charge density or the charge is not uniformly distributed throughout its volume, but the charge is dependent only on the distance from its faces. So one face is this, one face is this. So means if sigma 1 is the charge density on this layer, sigma 1 will be the charge density on this as well. On the second layer, if it is sigma 2, so sigma 2 on the second layer from this side will also be like this, and it will keep on going, and the entire the charge configuration is obtained. So now we will apply the Gauss's law. So we will make a cylinder, the cross-sectional area of which is A. So if we calculate the charge enclosed, apply the Gauss's law and calculate for the charge enclosed inside this cylinder. So what will you get? On this side, because of this, ECL is established. So epsilon naught ECL into dA on the left side, and epsilon naught ECL into dA on the right side. R and L is for representing the left side and the right side, will be equal to the entire charge within this cylinder. So here we got sigma 1, sigma 2, sigma 3, same way sigma 1, sigma 2, sigma 3. So we can say the charge enclosed will be sigma 1A, sigma 2A. A is the cross section area of this. So on. So sigma 1A. A is what? Sigma 1 into A will be the charge on this area. Q1, we have assumed that Q1, Q2, Q3 and so on. And let us say that Q1 plus Q2 plus Q3 plus so on is total in Q. So we can reduce this equation to epsilon naught ECL dA plus epsilon naught ECL dA for the right side. Integration like this will be equal to Q. A is the cross section, so this integration will be for ECLA, epsilon naught ECLA. So ECLA you will be getting as Q by 2 epsilon naught A. So Q will be 2 epsilon naught A into ECL. This is your equation number 4. So now you have Q known and E known. Okay, so we will be calculating the force on this cross section. That will be equal to, we will be putting the value of Q and E. Q is this much, E is E1 plus E2 by 2. Now for ECL, we will take the help of equation 5, because equation 5 we have calculated ECL in terms of E1 plus E1 and E2, and that is equal to E1 plus E2 by 2. So we will be getting 2 epsilon naught A into, in bracket, E2 square minus E1 square. In the question it is being asked force per unit area by the E field. So A, if we will bring down, so this will become epsilon naught into, in bracket, E2 square minus E1 square divided by 2. So this will be the force per unit area on the charge layer, and this will be your answer. So hopefully you understood the concept. In case of any problem in understanding, please write in the comment box. I will explain. Go through my write-up. It will give you ease in understanding. And please subscribe the channel. Thank you very much.